In this lesson, you will learn to distinguish between intersecting, parallel, and skew lines, to state and apply the theorem about the intersection of two parallel planes by a third plane, as well as how to identify the angles that are formed when two lines are cut by a transversal. Now there's a lot of definitions in this lesson, so let's just jump right in and we'll get to the different terms that you need to know for this lesson. First term is parallel lines. Parallel lines are coplanar lines that do not intersect. Remember, coplanar means lines that are in the same plane, and they do not intersect, meaning they do not cross over each other. So for example, here we have two parallel lines because they are on the same plane and they do not intersect each other. So these would be parallel. The symbol for parallel are two vertical parallel lines like this. Next we have intersecting lines. Those are lines that cross each other. So right here we have two intersecting lines. They cross right here at this point. Next we have lines that are skew. So skew lines. And what these are non-coplanar lines that are not parallel. But not only are they not parallel, they also are not intersecting as well. So for example, we see in this picture that we have a cube and we have different sides of the cube. Now if you were to look at lines YR and WZ, for example. So YR is right here and then WZ is right here. Notice the YR is on the bottom right of this cube and WZ is in the back corner. And they are not intersecting because they are on different planes, but they're also not parallel either. So that would be just one example of skew lines. We have other lines in this picture that are skew, obviously. We have like X and Q. Line XQ would also be skew with WZ, and we have other options as well. So some more terms with parallel. Looking at the same picture, we have what we call parallel planes. So those are planes that are parallel. So for example, if we were to look at plane X, Y, R, Q, so X, Y, R, Q, this plane right here, and then also W, Z, S, P. So W, Z, S, P. So looking at the cube, we have the right side and the left side. Those would be parallel planes because those are planes that do not intersect. Next, we have parallel lines and parallel planes. So a parallel line and plane would be a plane and a line that are parallel to each other. So they do not intersect. An example of this would be QX and plane SRYZ. So QX right here, and then plane SRYZ. Be down here. We have a parallel line and plane in this case. The line and the plane do not intersect. And then also ZR and plane WPQX. So ZR, we are connecting the Z and the R, as well as plane WPQX, which would be up here on the top. So once again, these would be parallel because they do not intersect. The plane on the top is the top of the cube, and then the line ZR is on the bottom of the cube, and they would not intersect, so they are parallel. Now in contrast to parallel planes, we have what we call intersecting planes. And those are two planes that intersect. So for example, over here on the right, we have two planes intersecting. They cross over each other. And the question would be, what shape do the two planes form when they intersect? So looking at the picture over here, we have the red plane and the blue plane. And notice where they cross, where they intersect. They intersect right here along this line. And remember, planes by definition would keep going forever for infinity. But when you're drawing a picture, you cannot obviously draw a picture that keeps going on forever and ever. So if you can imagine this going on forever, the line would also go on forever where they intersect. So they intersect to form a line. Now what if we had two intersecting planes, such as in this picture? So here we see that we have the red plane being intersected by the two blue planes. Now the question is, when we have the two blue planes intersecting, and if these two blue planes are parallel, then what happens is the two lines of intersection, here and here, because the planes are parallel, then the lines where they intersect would also be parallel. Now let's talk about intersecting lines for a minute. Here we see three examples of intersecting lines. We have the two blue lines, and the red line intersects both of them. So in each of these pictures, we have the blue lines being intersected by the red line. Now the term that we give to that red line that intersects multiple other lines is the term transversal. Transversal, by definition, is a line that intersects two or more coplanar lines in different points. So each of these examples, the red line would be a transversal. Now let's take a look at the next picture over here. We have two blue lines and the red line cutting through. So the red line would be a transversal because it is cutting through multiple lines. Now notice that when the red line cuts through, that we have different angles that are created. Here we have 1, 2, 3, 4, 5, 6, 7, 8 different angles. Now there are various names that we can give to the different angles that we have in this picture. So first off, we have what we call interior angles. Interior angles are angles on the inside. And when we say inside, we're looking at the two blue lines. They're on the inside of the two blue lines. So angle 3, 4, 5, and 6 would be on the inside or between those two blue lines. So 3, 4, 5, and 6 would be interior angles. And then exterior angles would be on the outside of the two blue lines. So you're looking at 1, 2, 7, and 8, all being on the outside. In addition, we have what we call alternate interior angles. So what these are there two non-adjacent interior angles on opposite sides of the transversal. Now that's a mouthful of a definition. What does that mean? Well, for example, if you were to look at angle 3, angle 3, 4, 5, and 6 are all interior angles. Now an alternate interior angle would be an angle paired up with angle 3 such that it is on the other side of the transversal. So the red line is a transversal, so it needs to be on the right side to be an alternate interior angle with angle 3. But angle 4 does not count because it needs to be non-adjacent. Adjacent means next to, so it cannot be angle 4 because it has to be non-adjacent. So angle 3 and angle 6 would be considered alternate interior angles. Also, if you look at angle 4 and angle 5 would be alternate interior because they're on opposite sides of the transversal and they're not adjacent, and they're also on the interior of the two blue lines. Next, we have what we call alternate exterior angles. So by definition, these are two non-adjacent exterior angles on opposite sides of the transversal. So looking at angle 1, for example, angle 1 is on the exterior. It's on the outside of the blue lines. So an alternate exterior angle would be an angle that is on the other side of the transversal. So you're looking at angle 2 and angle 8. But it has to be non-adjacent as well. Angle 2 is adjacent, so angle 2 would not be an alternate exterior angle. We're looking at angle 1 and angle 8. So angle 1 and 8 would be alternate exterior angles. Also, we have angle 2 and angle 7. Those are also alternate exterior angles because they're on opposite sides of the transversal and they're both on the outside of the two blue lines. Next, we have what we call same side interior angles. So interior means on the inside, so we're looking at angle 3, 4, 5, and 6. Same side means on the same side of the transversal. So looking at angle 3, for example, angle 3 is on the left side of the transversal. So to be a same side interior angle, it needs to be on the same side, or the left side of the transversal. So we're looking at angle 5. Angle 3 and 5 are both interior, and and they're both on the same side of that transversal. So angle 3 and 5 would be same side interior, as well as angle 4 and angle 6 would be same side interior. Next we have same side exterior angles. These by definition are two exterior angles on the same side of the transversal. So the exterior angles are 1, 2, 7, and 8. Those are on the outside of the two blue lines. Now to be same side exterior, they need to be both on the same side of that transversal. So looking at angle 1, on the same side of the transversal would be angle 7. So 1 and 7 would be considered same side exterior angles. Also, we have angle 2 and angle 8 would be same side exterior because they're on the same side of the transversal and they're also exterior angles. And then lastly, we have what is called corresponding angles. Corresponding angles are two angles in corresponding positions relative to the two lines. So what this means is if you were to look at the groups of angles that we created, here we have 1, 2, 3, and 4 up here on the top, and on the bottom we have 5, 6, 7, and 8. Now notice angle 1 is in the top left corner of this group of angles. And then the corresponding angle would be also in the top left corner down here. So angle 5, notice, is also in the top left corner. So angle 1 and angle 5 would be corresponding angles. Looking at angle 2 is in the top right corner, and angle 6 is also in the top right corner. So angle 2 and 6 would be also corresponding. And then angle 3 and angle 7 are both in the bottom left, so those are also corresponding. And then angle 4 and angle 8 are both in the bottom right corner, so those would also be corresponding. And lastly, we'll finish this lesson with a quick review from a previous lesson. So the review includes vertical angles as well as adjacent angles. So remember, vertical angles would be something like 1 and 4. It's like these are across from each other, so those are vertical angles. Or 2 and 3 would be vertical, they're across from each other. 5 and 8 are vertical, and 6 and 7 are vertical because they're across from each other. And then remember that adjacent angles means angles that are next to each other, and more specifically, they're sharing a vertex and a side. So for example, angles 1 and 2 would be adjacent because they're sharing this vertex right here, and they're sharing this side right here. So that would be adjacent. Angle 2 and 4 are adjacent for the same reasons. And then 3 and 4 are adjacent, and 1 and 3 are adjacent. And then down here we have angles 5 and 6 are adjacent because they're next to each other, sharing a vertex and a side. And then 6 and 8 are adjacent. And then 7 and 8 are adjacent. And then also 5 and 7 would be adjacent because they're sharing a vertex and a side. So just a quick review of terms we've talked about in the past, but you will use this in this particular lesson for different things with the practice questions, and it's just a good review as well. So that concludes our lesson for today. We will see you next time.